Okay, so going back over the formula because we are still having trouble remembering the parts of it. Now, whenever you have numbers, variables, whatever, on this side, on the right side of the equal sign, this is what we're labeling, or this is what you call your equation. Because some people don't, anytime I say B is greater than 1, B is less than 1, you don't know what I'm talking about. I'm grabbing the B from the formula, from the equation. In the equation, it's the variable B. Just like here in the equation, your variable is A. But if I'm mentioning, or if I'm talking about the variable A, what am I actually talking about? The what? A represents the initial value. Good. Let's start there. Initial value. Initial value. Other words that you could find instead of initial value would be something like start, your starting amount. Starting amount. Nah, not yet. Starting amount or beginning. We begin with something. Begin. I open an account, beginning. Sorry, I have to think about how to spell. I open a bank account. I first purchased a car. Any of those words, if it's some type of phrase, you're finding those words in a word problem. They're coming from a word problem. When you refer to the y-intercept, yes, it is the y-intercept. The y-intercept is a location on the graph. So if I'm looking at a graph, I will refer to it as a y-intercept. If I'm looking at a word problem, I would refer to it as the initial value or the starting amount. We began with this, we began with so-and-so. Or if I say, what is my value of A? I'm referring to the equation, but all three of these represent the exact same number. I could say, I started or I opened a bank account with $1,000. If I'm looking at a graph, it will represent that $1,000 on my y-axis by putting a point on the y-axis at the number 0, 1,000. It's a y-intercept. Or if I have an equation, I could have a 1,000 right here in front of the parentheses. But that 1,000 can be interpreted 3 different ways. You could either have words from the word problem, a point on the graph, or you could actually be looking at the equation, but all 3 are the same number, okay? Now, the X, remember, this variable X, that is what makes our exponential functions special, because our variable or X is in the exponent spot, exponential function. Exponent, you see the word exponent in it, exponential, exponent. Your X is an exponent. Your X is an exponent, exponential. You had an assignment where you had to categorize several equations, several formulas. So the only way to know if it's an exponential is if you have that X in the exponent spot. Now, what does that actually represent? We actually wrote it down at least 1 or 2 times. What does that exponent represent? Look at your day 1 notes. Look at your notes from Thursday. What? It is an exponent. Your X is your exponent. That's what it is. But what does it represent? It represents time. We talked about several ways to represent time. You got days, months, years. Time is very, very easy to remember or to know what it is. But other things would be some, we're going to describe them as intervals. Intervals. We had that V and R look exactly the same. So intervals, we had an example where we were talking about Stacy's family and the x-axis was going by the amount of generations. So intervals can still be measured It's just a different sort of time. It's not more concrete like days, months, years, and seconds, minutes, whatever. Like, so we also had an example where there was a tennis tournament and you had amount of rounds. So intervals is a little bit more general. I'm going to go ahead and write those examples. These are the examples that we've already seen. Rounds in a tournament, generations. I don't think there's anything else that we've actually seen that is not actual time. Okay. All right. B, what does B represent? B is called your factor. B is called your factor, and your factor is also known as your multiplier. We call it the multiplier because that's the number that we are multiplying to get to the next value. We start at $1,000, but I'm multiplying it by so and so number every single time to get to my next one, where it's a multiplier. Now, the only way to get the factor, if you have words such as half, we've seen the word half, we've seen the word double. Double means to half is just 1/2. Double means to multiply by 2. What about triple? You should have seen that one in your assignment. Triple. That's just a factor because you don't see a physical percent sign. If you don't see a physical percent sign, it's considered just your factor, especially if you're looking at a word problem. These are words that you would find in a word problem. I'm just put word prob right there. Okay. Those are words that you'd find in the word problem. But if you see a physical percent sign, we're actually describing what? Not the one, we're describing the. If you see a physical percent sign, what are we describing? The rate, the rate. So you get the factor. If all you're given is half, double, triple, you don't have to worry about this little formula right here. But if you're given a percent type number, then you do have to worry about it. It's 1 plus or minus R. R meaning the rate, and we'll also write that down. So let's say we go ahead and we're going to split it into growth and decay. The formula for growth will be 1 plus R. If you take that 1 and add your rate, in the parentheses, you're going to have a number bigger than 1. That's why we write B is greater than 1. In the parentheses, if you have a number bigger than 1, that represents exponential growth. Decay. Factor starts at the number 1. If you subtract the rate, if you're given in a word problem a percent type number, you have to start with this 1 minus that percent. If you do that, you're going to end up with a number less than 1 inside the parentheses, but never a negative. So B has to be in between 0 and 1. You never have a negative number in that parentheses, and you'll never be given an example with an actual negative. But just for reference, R means the rate, and your rate is always written as a percent. Your rate is always written as a percent. Okay. All right, go ahead and turn the page. Does anybody need that, need to write how to turn a percent to a decimal and decimal to percent? All right, let's say we start off with the decimal. Decimal to percent. Decimal to percent. So you take the decimal, so say 0.08, and you multiply it by 100. And that will give you a percent. If you want to go backwards, if you start off with the percent and you want to go to decimal, you take the 8% and you divide by 100. The opposite of multiplying is to divide by 100. You don't actually type a percent symbol in the calculator, but If you take 8 divided by 100, it gives you 0.08. Another handy tool for you to use. What about what? A fraction to percent. Well, we already know how to convert a fraction to a decimal, so, and then a decimal to it. But I'm not about to write that down. Y'all need to do some of this stuff on your own. All right, here we go. Number 1. First, we're just going to focus on finding the values and creating that equation. We're writing your exponential equation. So it says a bank account is earning. Earning means what? Growth or decay? Growth. We're going to do a lot of underlining, a lot of labeling. Growth, earning an annual compound interest. Bank account earning annual compound interest was opened, should be ED, opened with $200. We opened with $200. So what is that going to represent? Your initial value. If that's the opening, that's the beginning. And it says with no additional deposits or withdrawals. Every year that account earned 12%. There's a number that's going to be very important, but because it has that percent symbol, what does that represent? Does that represent the factor or the rate? It only represents the rate. I'm just going to draw that. 12%. That's going to be important. I'm not going to use it yet. Now it says write a function that models the situation reflecting the amount the account has after 18 years. 18 years. Years represents what? Time. And where do you see time? Time is a what value? An X value. Time is an X value. Years is time. Time is an X value. All right. So let's start answering these questions. What is my initial value? $200. $200. You're going to have a lot of questions today asking what does it represent? It's the opening amount of the bank account. And we're actually going to practice writing in words on number 5 and 6. So I'm just right now, you need to know it's $200. Now, part B, the factor. The factor. Is it asking for the percent? No, because the factor is not the rate. In order to find the factor, I first have to convert this to a what? Decimal. And I can do that by dividing by 100, like I showed you on the front page, or you take this percent and move it back to the front. So 0.12. Your decimal is technically where that percent sign is. So 1, 2, and it gives us 0.12. Now we have a formula that we've been using. It's 1 plus or minus the rate. And that will give us our factor. It will give us the number that should be in the parentheses. But because we are earning, is that 1 plus or 1 minus? Plus. I've already converted that percent into a decimal. So now I can go ahead and insert that right here. I converted this 12% to a decimal and there it goes. So now I have to add it. 1 plus 0.12 is 1.12, easy peasy. And that is my factor, 1.12. That's what goes in the parentheses. Now it's time to put it into our equation, into our formula. So our formula is f of x equals what? 200. Your initial value goes in front of the parentheses. And then what goes inside the parentheses? 1.12. And x on the outside. Does x go like this? No, it's a smaller x and it's at the very end. It goes in the upper right-hand corner because it's an exponent, okay? Now we want to know what would the value be in 18 years. 18 years, we already labeled it up here. It's an x value. So I need the same equation, but I'm going to replace that x with the number 18, okay? So I'm going to write my equation, 200 times 1.12. And instead of an x, this time I'll replace it with an 18 right there. Where the 18, that is my time, that is my years. Okay, that's an 18, by the way. There we go, much better. So you can actually type all of this into your calculator. Type in 200, make sure you're using your parentheses and everything. Oh my goodness, documents, maybe. There it is. Type it in, don't be lazy. Don't wait for Ms. Ramirez to type it in for you. Ms. Ramirez is not gonna be typing everything in for you on the day of the STAR test. $1,537.99. We're describing what? Your Y value describes what? No, X describes a time. Your Y describes the amount. Remember, we had our initial value was a dollar amount, an amount in dollars. So the answer is 1,537.99. I don't keep anything after that decimal. You would not round up in this one because it gives you 0.99 with the 3. The 3 does not round the 9 up. So it does stay as that. Okay. Know where to find the numbers, know what they represent. Main takeaway. What? Here? Amount in dollars. I just didn't write the whole word. It's abbreviated. Okay. Number 2. The population of an apartment building is what? That 4,000 people represents what? This is my initial value. That means that's how many people I have to start off with in my apartment building. Every month, 12% of the tenants move out. You need this 12%, but is this 12% the factor? No, because of that percent sign, that represents the rate. I'm just gonna put a little R over there. Now the tenants are moving out. They're not moving in. So if they're moving out, what do we see? Decay, decrease. Okay, write a function that best models the amount of tenants that there will be left after how many? 4 months, because that's time. That is my X value. All right. So first thing I'm going to do is I'm going to come over to the side and convert that 12% back to a decimal so I can use it. 12%. I grab the percent, move it 2 to the left, or I divide by 100 and it gives me that 0.12, which we just saw in the previous example anyway. All right, let's start answering the questions. What is my initial value? 4,000 what? People. My initial Y value is 4,000 people. So my Y values describe people. All right. The decay factor, it's asking specifically for the factor, not the rate. So I need my formula. 1, because we're moving out, minus the rate. 1 minus the rate will give me the factor. What is the rate? 0.12, but 1 minus 0.12 gives me 0.88. Now I'm going to keep that 0.88 in my parentheses. Okay. Now we can write the equation. My equation, my formula, f of x equals, what goes right after the equal sign? 4,000. And what goes in the parentheses? 0.88 to the power of x. To the power of x. Okay. Now, population in how many months? 4 months. So where am I going to put that 4 months? Where do I plug that into my equation for the exponent? So let's write that in. 4,000 times 0.88 to the power of 4. That little 4 represents my months. That's where it goes in this little spot. And what do we get? How many people? What is my Y value? Do we keep the decimal for people? So just 2,398. And we said that the Y value describes people. That's why we are not, or I'm going to write it as this number of tenants. Tenants. It's your number of tenants. That's why we don't keep a decimal. We're describing people. Tenants are people that rent a property. You do not round with people. You just keep, yeah, don't round. You cannot round up with people. What's up? Only with money. All right, number 3. New York Mets sign a new player. New player. He's brand new. For how much? 8 million. So my initial Y value is what? 8 million. I'm just going to put mil for now. I'm actually going to write the whole number out in the equation, but for now I'm just going to write 8 mil. All right. And it says his salary, what? Increases. So that means we're adding 3%. Is it 1 plus 3? No, because what do we have to do to that 3%? We have to convert it back to a decimal. You treat the percent symbol as the decimal and you move it 1, 2, filling in any gaps with a 0. So 3% is 0.03. But once again, this is still the rate, okay? This is still the rate. So in order to find the factor, I need to take that 1, add or subtract the rate to get my factor. If he's increasing, we're adding the rate. What is that number? 0.03. So 1 plus 0.03 is 1.03. Sometimes it's easy, sometimes it's not. 1.03. Questions on where we got this number? Okay. Now it's time to put it into the equation. My equation is f of x equals, all right. I'm going to keep the 8 mil in words. Yeah, too many numbers so far. And then what goes in the parentheses? To the power of x, to the power of x. 8 million, because that's my initial Y value, times 1.03 to the power of x. Now that we want to know what his salary is going to be in 6 years. What is his salary going to be in 6 years? Years is time. Years is time, and time is an x value. So if they give us the x value, what is the Y value? My Y value, before I start plugging in, my Y value describes what? It describes money, and we're talking about his salary. We're talking about his salary. You need to know what all of these things are describing in case your answer choices are in word form. Okay. All right. So let's plug that number in. 8 mil. Instead of writing just an 8, this time I'm going to write it out all the way. 8 mil. 1, 2, 3, 4, 5, 6. 1.03. And what's my exponent this time? 6. That 6 represents my years. Go ahead and plug that into your calculator. What do you get? Lord. Okay, so write small. 9,552,418 with how many cents? 37 cents. Don Terry said they could keep the change. Nah, I want my pennies. Give me my pennies. Hey, rich people don't get rich by not being stingy. You got to be stingy. Ready? Questions? Concerns? I don't know how to find these numbers. Here we go. Almost done. 3 more examples. A xylophone. Xylophone is made up of 8 wooden bars. Starting, there's my word, starting with the first bar at what? 14 inches. So that's going to be considered my initial Y value, my starting amount. 14 inches. I'm just gonna put 14 inch. All right, next it says for bars 2 through bar 8, the length is 15%. It has a percent symbol, so what is that describing? The rate. My rate is 15%. But once again, your rate is not your factor. What do I do to the rate? I convert it back to a decimal. So take that percent, 1, 2. So as a decimal, 15% is 0.15. Now I use my formula. 1 plus or minus the rate gives me the factor. How do you know it is minus? Where? How do you know it's decreasing? If it's only 15% of the length, that means you're only using 15 out of the 100 points. Maximum amount, or with an object, maximum amount is 100%. If you're only giving 15% effort, are you giving more effort than you can? No, you're giving less effort. If I tell you that on your homework, you're only giving me 15% effort, are you giving me more effort? Or are you giving me less effort than you can possibly give me? Less, so it's decay, okay? Now that 1 minus 0.15, what does that give us? 0.85. So 0.85 is what goes into our parentheses. Man, I'm telling you, I went to bed at 4 a.m. So this is like, all right. So what number do I put right after the equal sign? 14. Enrique, I can hear every word in that song. And what number goes inside of the parentheses? To the power of x. Okay. Now my y value describes inches, but what does bar 6 describe? This is my x, this is my interval. So if my x value is 6, what is my y? Once again, y value describes the length in inches, the length in inches. So let's write that equation with the number plugged in. It'll give us 14 times 0.85 to the power of 6. That is my bar number. Yep, 5.28 inches. 5.28 inches. So if you have a xylophone, you start off with a bar. By the time you get to the 6th bar, 3, 4, 5, 6, there's my 5.28 inches. Okay, just in case you're wondering. 15% of it, meaning it gets smaller and smaller and smaller. My xylophone. I don't know. That's my drawing of a xylophone. I don't know. Anyway, number 5. This time on number 5, it's asking, we're not really going to do a whole lot of math here. We're not going to be plugging in, because the question is, what do the values represent? Anytime you see that word, anytime you see the word represent, it wants to know in words, in sentence form, in words, not a full sentence. I'm not an English teacher. I don't care. In words, what does that value describe? So first things first, what is my value of A? A is my y-intercept. What is the y-intercept here? 5. 5.00. What does that describe? What does it represent? The initial value of what? Initial, or the starting what? Starting, to show how the balance, the starting amount, the starting balance. We're talking about a savings account. So we're talking about an initial amount of money, okay? Next, B. B is your factor. What is the factor? 1.012, okay? What does that 1.012? Increase, because that number is what? Bigger than 1. The number is bigger than 1. So my factor, my B value is greater than 1, meaning my balance is going to increase. Balance increases. You can have an answer choice that says my balance increases, or you could also have an answer choice that says my balance decreases. You need to know if that number is bigger than 1, it's increasing, okay? Let's look at the rate. Rate has to be written as a percent. I'm not given a percent in this word problem, but I can grab it. I can take it from the factor. I know that we start with the number 1. 1 plus something will give me the rate, and I know what the factor is. My factor is 1.012. So what did I add to 1 to get to 1.012? 0.012. 0.012. 1 plus 0.012 gives you 1.012. So that means my rate is 0.012, but my rate has to be written as a percent. Take the decimal, move it twice to the right, and it's 1.2%. So in the word problem, you could see the words increases by 1.2%. Increases by 1.2%. With the factor, it'll just tell you in general, the balance is increasing. With the rate, it'll actually give you a percentage. It'll say increases by this amount, okay? T. T is my time. T is my time. Remember, this can be described now. Does it tell you a specific time here? No, but it can describe days, months, years, whatever, okay? But it's time. Number 6. What is my initial value? What is A? 245. What does that 245 describe? The starting amount of what? Starting amount of bacteria. Know how to describe this in words. Gives the number of bacteria, the starting amount, the starting number of bacteria. B, what is my factor? 0.60? 0.60. That means my factor, is my factor greater or less than 1? My factor, my B value is less than 1. And because my B value is less than 1, what is happening to the bacteria? The amount decreases, or the balance decreases. Amount decreases. The amount decreases. Good. Now we got to find the rate within the factor. Rate has to be written as a percent. Okay. If we're decreasing, that's 1 minus. We know that the factor is 0.60. So what did I subtract from 1 to get to 0.60? 0.40. 0.40 has to be written as a percent, 1, 2, giving us 40%. So in words, it could be written as decreases by 40%. I'm just going to put DEC by 40%. Decreases by 40%. X is time. This one does give us a specific amount of time. Days. You see that right there, X amount of days. Okay. I know.